Okay, now we are on the second part of your sequence and series, which is geometric sequence. In last class, we covered arithmetic sequence, where every next term coming with the constant difference. The difference between arithmetic and geometric sequence. In geometric sequence, every next term coming with a constant ratio. So, for example, if I'm writing a sequence something like this, 2, 4, 8, 16, ... So you can see every next term is coming with constant ratio. So 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So ratio is constant. So let's start with the geometric sequence concept and main terms. As we know that in arithmetic sequence, first term is denoted by u1. So here also first term is also u1. Here constant ratio will come. Which is generally denoted by r, which is again next term divide previous term. So that is why you see that I'm dividing 4 divided by 2, 8 divided by 4, 16 divided by 8. I'm not doing 2 over 4, 4 over 8. Now here I know the first term is 2, second term is 4, third term is 8, fourth term is 16. Ratio is simple because I know the table of 2. But in case if I'll ask you in the same sequence, find out the 100 term or something, a very long term, it is again a time consuming process to write down all the terms up to 100 term. So to again find any term in geometric sequence, it is denoted by un. U stands for term, n stands for which number of term you are taking. If I'll say 100 terms, so your n should be 100. And the formula for this, I'm writing the way it is given in a formula booklet, which is u1 times r raised to n minus 1. Remember this, exactly same way it is given in your formula booklet, but I recommend please make a bracket for r, because the raised to power n minus 1 is only for r. So first you take the raised to power of r raised to n minus 1. Whatever term you will get over here, multiply by un. That gives you the un term. If I'll ask to find out the sum, when I say sum, it becomes a series. Till now it's a sequence. So series of geometric sequence is Sn is equal to u1 times 1 minus r raised to n over 1 minus r. You can see here r raised to n is in a bracket, and whatever term you will get, you subtract from 1. This is used if your r is less than 1. That is why you are subtracting from 1. That is why 1 is bigger than your ratio. There is another formula which is un is equal to r raised to n minus 1 over r minus 1. This formula is generally used if your r is greater than 1. That means r is bigger than 1. That means 1 is subtracted from r. The last part of this sequence, it is called as an infinite geometric sequence. So in that case, if I want to find out the sum, the condition for ratio has to be between 0 and 1. If it is a more than 1, we cannot find out the infinite geometric sequence. For example, I reverse this sequence. Instead of starting from 2, I am starting from say 16. So 32 divided by 16 divided by 8 divided by 4 divided by 2. Basically, every next term is coming with the constant ratio of 1 upon 2. Then next term becomes 1, then next term becomes 0.5, then next term becomes 0.25, then next term becomes 0.125. If you'll see the trend, you can go infinite way, but you will never reach 0. Yes, obviously calculator has some restriction, so it will, after some terms, it will show 0, but 0 is not a finite number. So you can see the trend now 0.125, the next term would be 0.0625. What do you see? Right now it's 2 digit, then 1 digit, then 1 decimal, here also. Then after that you can see one more 0 before it is added. So more you will divide by 2, the more you are approaching 0. So in that case, your ratio, if I'll do that, 16 over 32 is same as 8 over 16, is same as 4 over 8, is same as, is equal to 1 over 2. 1 over 2 is 0.5, which is less than 1 or more than 0, geometric sequence, infinite geometric sequence. And in that case, if you will apply that same logic over here, then your S infinity is equal to u1 over 1 minus r. I'm sorry, here it is not n, it is u1. Reason why the same formula, this is the same thing. Instead of Sn, I'm writing S infinity, because if you'll see, your ratio is more than 0 and less than 1. So if you'll see 1 minus whatever this ratio, which is more than 0 and less than 1, is basically approaching what? 1. Because r raised to n is a decimal, which is between 0 and 1. And if you increase the power, say 100, 200, 1000 or something, then r raised to n becomes 0, which is why that becomes 1. And that is why 1 minus 0, which is basically 1. So that is why S infinity formula is u1 over 1 minus r. So these are the concept we are going to use for the geometric sequence. All these formulas are given in a formula booklet except R. Thank you.